Today, I wanted to talk about AI-powered ADEM and the value that it offers for enterprises. So we will be talking about some of the top use cases, some of the top pain points or problems that AI-powered ADEM will address for your enterprises. So before we get into the use cases and the challenges that we will address, I just want to give a brief overview of AI-powered ADEM and what is it really made of. So I just wanted to give you an overview of that. So first, let's look at why AI-powered ADEM came into place. So with users being more distributed, with a workforce coming from all kinds of places, and traffic going towards several destinations like SaaS, on-prem data centers, or data centers hosted in the cloud. So we have traffic going everywhere. Now, IT has the problem of making sure that users are continuously monitored, irrespective of where they're coming from, where their traffic is going to, what kind of middle mile connectivity exists. So irrespective of all that, there needs to be a constant way, a continuous way to monitor user experience to make sure that end users have a guaranteed or a consistent application experience. Also, having several management solutions, having several monitoring tools burdens IT because there is a need to manually correlate all of the insights gathered from these siloed management solutions. Now, what you're looking at here is what I call the service delivery chain. So a service delivery chain is the path that application traffic takes from an end user's device all the way towards the destination, which is the application. So the user could be working from home or coffee shop or from a branch office. So irrespective of where the user is working from, there are several segments, several hops in the path of the application traffic where performance impact could be introduced. Now, there are several monitoring solutions available for monitoring each of these segments independently. However, there is no way of, or there is no solution that exists which can monitor the entire service delivery chain and provide correlated insights. So there seems to be a serious challenge here with respect to monitoring user experience. Now, for any organization, there are two categories of issues that could happen. So one is low frequency issues, which are high impact, like something that affects a large population of users. And then there are high frequency issues with low impact. So think about something like a regional server issue, a regional web server issue, or regional ISP brownout or an outage. Now, for both of these issues, the problem is the time taken to resolve, the time taken to detect a problem is considerably high because of the lack of correlated insights from multiple management solutions, and then IT having to rely on legacy troubleshooting playbooks. So there is a lack of information here, and there is a lack of correlation here. There is a lack of way to highlight or provide a heightened visibility to root cause events. Now, AI-powered ADEM provides that visibility to enterprises. And how do we do that? So the way AI-powered ADEM works, so I would like you to think of it as having two critical verticals. One is observability, and then there is an AI ops part of ADEM. So observability provides proactive, continuous monitoring along the service delivery chain. So it could be the end user's device, home network, service provider, application, infrastructure services like auth server, DNS, data center connectivity, branch office performance. Now the AI ops part of it collects all of this telemetry. It learns and understands your network, builds a baseline, and provides anomaly detection. So we are able to indicate to a network administrator or the help desk team whenever there is an anomaly. We raise an incident. We notify an administrator whatever mechanism that they want, either using integrated ServiceNow integration or using email notification or webhook integration. We are able to notify an administrator. And the diagnostics that we build on top of the telemetry that we collect uses a significant amount of AI ML technologies. And all of this provide root cause isolation and remediation for network events as well as user experience incidents. Now, I'm going to talk to you about some of the top use cases where we will see all of this in action. Now, as a result of this AI-powered ADEM, bringing in the power of observability and AI ops together, we are able to see that enterprises are able to have a drastic reduction in the mean time to detect a problem, and hence the mean time to remediate a problem also significantly improves. Now, I just want to go a little deeper into observability. So when I said observability, I want to show you the holistic observability capabilities that we offer across the organization and the capability to drill down to a per user level or a per application level. So what you're looking at here is what we call the SASE Health Dashboard. So this is your enterprise dashboard. This shows a bird's eye view of how an organization is performing and where the performance bottlenecks are. So one look at this dashboard, an administrator instantly knows how the organization is performing and where he should focus in order to make sure that user experience is improved. So with AI-powered ADEM, the observability that it offers, we are able to provide that holistic visibility end-to-end for an entire organization. Now, another example that I want to give here is, say, for example, Zoom. An application like Zoom, which is consumed by several enterprises. It is quite common to see issues where audio freezes or maybe there's a screen share issue. Now, users can open help desk tickets. Enterprises can subscribe to Zoom quality data. But how do they even figure out where the performance bottleneck was? So why did this person's audio why was this person's video frozen during this particular meeting? Why was the screen share frozen during a certain exec meeting? How are administrators able to get that visibility? So today there is no such visibility where where there is a correlation between Zoom performance data and the root cause of a problem. With the Zoom integration that Palo Alto offers, we are able to narrow down and pinpoint the root cause for any Zoom performance impact. So say, for example, a user is in a very critical exec meeting where he's presenting and his screen share froze, his presentation was interrupted. Now, if he opens a help desk ticket, we have the capability to go down, drill down into that particular meeting and find out exactly why that user screen share froze. What was the problem that caused that performance or that interruption in his presentation? So we'll talk a little more about this and I'll show you specific use cases. But with this integration, we are able to ensure that end users are provided actionable insights to ensure these performance bottlenecks do not happen. Also, we have a feature called self-serve, which is able to provide insights to the end users so that they don't even have to open help desk tickets. They are proactively notified and intimated about performance bottlenecks so that they can address those issues without even having to open a help desk ticket. The AI ops portion of it provides root cause analysis, collects telemetry, does correlation of multiple network events, and provides an impact analysis in order for administrators to understand the size of an impact. And then based on all of this information, AI ops provides remediation playbooks in order to fix these issues quickly. Now, I've given a quick overview of what ADEM observability does, how AI ops enhances all of the telemetry that we collect through ADEM observability. Now let's look at some of the top pain points, some of the top challenges that enterprises face and how AI-powered ADEM addresses these challenges. So the first use case that I want to walk you through is end user experience issues. Example, an end user opens a help desk ticket saying, hey, my applications are slow. I have to refresh my applications multiple times. So this is what an end user says in a help desk ticket. Not all the end users are technically savvy to understand the nuances of applications or to give detailed information for administrators to understand why the problem happens, or there is no triaging help. So end users open a help desk ticket in like very simple terms saying my application are not responding, they are slow. How does an IT administrator or a help desk team, how do they troubleshoot something like this? Now, if we were to wear the hat of a help desk engineer, we know that there are only a million reasons why an end user can run into a problem like that. Slow application, the problem could happen anywhere. Now, if you look at traditional IT troubleshooting playbooks, it involves several steps. Manual execution is required, and correlation across multiple tools is required, because for every segment troubleshooting, like for example, for Wi-Fi or for internet service provider, there are multiple tests that are required, and all of this data needs to be correlated. Now, we should also remember that users do not have not captured any historical data, so the help desk team does not have insights into what was the exact state of the network when the user ran into the problem. So there is a lack of historical data as well. So this requires a lot of back and forth communication, typically between an end user and the help desk team. So the time taken to detect or isolate the problem takes significantly longer, and then the mean time to resolve the problem also eventually increases. Now with AI-powered ADEM, since we are continuously monitoring the network, we are proactively able to identify or isolate where the problem lies and provide actionable insights to the end user. So let's see an example of how we exactly do this with AI-powered ADEM. So now let's say user Daniel Scott opens a help desk ticket saying his applications are slow to respond. Now, what you're looking at here is the SASE portal, the Prisma SASE portal. And right here on the users tab, I go to Daniel Scott, I filter Daniel Scott, and I go to his experience dashboard. On his experience dashboard, I see his score and all of the business critical applications that are monitored for Daniel. And just by looking at this, I can say that all of his applications are performing poorly. So the color legend that you have to remember throughout the session, wherever you see experience data, red indicates poor experience. Amber is fair or average experience. The user may or may not have problems. Green indicates all the segments are healthy. So right here, when you look at the applications, they are all highlighted in red. The score is highlighted in red. So all of the applications seem to be suffering. So yes, Daniel has some problem. Now, when I look at Daniel's app experience trend, I can see, yes, consistently, at least for the last 3 hours, he's been having some problems. Now, and when I look at his topology, I can see that his endpoint device is clearly isolated. So if you look at the other segments, wireless, local network, internet, Prisma access, these are all highlighted in green. These are all healthy. There are no issues. What has been isolated is the endpoint device and the application. And of course, we know that his application experience is not good, as confirmed by Daniel. Now, the endpoint device has been flagged or isolated as a potential contributor to the end user's performance issues. So when I hover over the endpoint device, I can see that his CPU and memory utilization are high. Now I know there is a problem with the endpoint device, and I know that it's likely because of his CPU and memory utilization spiking up. Now what you're looking at here is point in time data for 11:15 a.m. Now my next question is, okay, so has Daniel been consistently seeing this problem over a period of time? So I click on the endpoint device and I'm taken to the historical time series data. So what I'm looking at here is for 3 hours, but then I can go all the way back up to 30 days and I can look at his device behavior. So as a help desk engineer, I'm trying to understand what is his device typical behavior. Is this how it is always, and does that coincide or correlate to his poor experience issues? So when I look at his CPU and memory utilization, at least for the last 3 hours, it's been consistently high. My next question, why is the CPU and memory spiking up? So I look at the top 5 processes that are consuming high CPU and high memory, and I have insights into what's going on with his endpoint device. Now, as a help desk engineer, I've been able to instantly isolate where the problem lies. I know why the problem is happening, and I also have actionable insights which I can provide back to the end user and tell him, hey, it looks like these are the processes that are causing high CPU. Do you know what's going on with these processes? So with AI-powered ADEM, we've not just been able to provide visibility into what the user's experience looks like, we are also able to isolate the problem segment, and we are also able to provide actionable insights or feedback so that the user doesn't run into this problem again. Let's take a look at another example. So user Edward Stewart is also opening a help desk ticket saying he's having some kind of performance issues, his applications are slow, but his issue is that the issue happens on and off. It's an intermittent issue. So now when I look at his app experience trend, I'm looking at the last 3 hours. It looks like for a certain period of time, his application experience seems to be red, indicating it's poor, and then it gets better. So his application experience is green and healthy, and then it goes down again. So there seems to be some problem. Edward is right. He seems to have an intermittent application experience issue. Now we want to know why that's happening. So now when I look at his topology chart, it looks like his problem is originating from his wireless network. So when I hover over his wireless segment, I can see his signal quality and TXRX bandwidth are significantly low. So, and that coincides with the times whenever he has poor experience. Now, I want to know more. I want to know the historical data. I want to know what is his usual home network behavior. Now, when I look at the last 3 hours, I can see that his wireless network is showing a pattern which matches with his application experience. Whenever he has poor app experience, his signal quality deteriorates. So, or vice versa. Whenever his signal quality is bad, his app experience is also bad. And when his signal quality improves, it looks like his app experience improves as well. So it looks like Edward is probably working from home and is moving a lot inside his home. And whenever he moves far away from his access point, or maybe he is next to a device which is introducing wireless interference, and that's probably causing his application experience issues. Now let's look at another example. User Faith Powell is also experiencing application slowness. Now Faith's issues, so when I click on the app experience trend, a point in time when his application experience is bad, I can see that his internet segment has been isolated. Now, when I hover over the internet segment, I can see there's a significant amount of latency that has been introduced. Now, I want to get to the bottom of it. I want more details. I have historical data. I have layer 3 to layer 7 data. And I can see that there is some kind of network layer issue, which is introducing a significant amount of latency. Next, I want to see, okay, so this is within the service provider network, and I want more insights. What's happening within my service provider network? So when I look at this path visualization, or what we call as hop by hop insights, we are able to see exactly which hop within the service provider network is introducing this performance impact. So this visibility allows administrators to identify where the problem lies. So the mean time to detect significantly improves because it's already there. We are proactively, continuously monitoring. There is no data collection that is required. The first level of troubleshooting is already done. And because of all the telemetry that we collect, we are also able to quickly remediate the problem for the end users. Now let's look at the next use case for Zoom. So we talked about this example. A user is in an exec meeting, he's presenting. When he's presenting, the screen share freezes. He opens a help desk ticket for something like that. It's going to take a really long time to resolve a problem, especially because of the number of teams that are involved and the number of troubleshooting steps that are required. And sometimes it's not even possible to figure out why user XYZ had a screen share freeze for 5 minutes during his meeting. This is a very, very difficult question to answer for a lot of help desk teams. Now, with the Zoom integration that we have with Palo Alto, we are able to identify the performance impact, and we are also able to isolate the root cause for the performance impact. So what you're looking at here is the Zoom meeting experience dashboard for the entire organization. So this provides organization level insights. It shows for the organization, what are the total number, how many minutes were impacted, how many meetings were impacted, how many users were impacted. So this gives an overall view across the organization for the success of the UCaaS solution rollout. For the Zoom administrator, this is a valuable insight as to where he should focus his efforts on, how he should improve the performance of Zoom across the organization. Now, this root cause analysis shows the top root causes or the top reasons why Zoom performance was impacted across the enterprise. So this provides actionable insights to the administrator on how to make sure the success of Zoom is guaranteed in the organization. And we also can see here the list of top users who are experiencing performance impact for Zoom. And when I can drill down to the users dashboard. So now from the enterprise level, we have come to a single user. Now let's go back to our example where that user had a screen share freeze during a critical customer presentation. Now on his dashboard, I look at Zoom performance analysis. I see how many minutes were impacted, how many meetings were impacted. And not just that, I also can see the breakdown for audio, video, and screen share. So this tells me which part of his Zoom meeting suffered significantly. And there are also top root causes. These are the top reasons why this user has been seeing Zoom performance issues for the selected time range. Now, if I change the time range to last 30 days, I can identify, I can give this feedback to the user and saying, hey, this looks like your home network is introducing a significant amount of packet loss. Why don't you go restart your home router? That might fix issues for you. So I'm able to provide that feedback to the end user. Now, we talked about that specific use case, that meeting where the user screen share froze. What you're looking at here is the calendar view for the end user. Now, as you can see, these meetings are color coded. So a red indicates that the meeting was poor, amber indicates a fair average experience, and green indicates a good meeting. Now, if I want to troubleshoot further for a particular meeting, I can click on that meeting and it takes me to the telemetry collected specifically for that meeting. Now, this shows this user has 17 minutes of impacted video, poor video for this particular meeting, and the root cause for that is listed here. So we've indicated where the problem lies, and we've also captured why that problem happened, so that this closes that loop. This enables the end users to fix issues so that these issues won't recur for them again. Okay. Now let's look at a regional application performance issue. Let's say a regional group of users are having a performance impact. Now, to troubleshoot something like this, with the enterprises using legacy monitoring solutions, it takes time to even understand that there is a regional application experience issue that's happening, a regional performance impact that's happening. There is no way to surface a regional performance issue or a global performance issue for that matter. So it takes a lot of time is spent in just collecting these help desk tickets and understanding and realizing that there's the regional issue. And then the right teams have to be involved in order to understand why that problem is happening. Sometimes the ticket needs to be opened with a SaaS provider. So a lot of time is spent back and forth, bringing teams together, trying to correlate insights manually. With AI-powered ADEM, with the continuous and proactive monitoring that we are doing from several vantage points, not just the end user, not just the branch office, but also from the cloud, we are able to isolate quickly that there is a regional performance impact that's happening. So Palo Alto Networks has globally deployed cloud agents, which are continuously monitoring 100+ business critical applications. This also helps to offload the end users' laptops from running any kind of synthetic tests. So this monitoring happens continuously from our cloud agents, or what we call as Prismax's locations. Now, I'll give you an example. Let's say users in the North America region are experiencing a performance impact, let's say when accessing Dropbox. Now, what I'm going to do is I'm going to look at my cloud agent in the North America region, and I go to the experience dashboard of my cloud agent. I can see that for Dropbox, there seems to be some kind of a problem, an intermittent issue. The performance seems to drop sometimes, it's bad sometimes, and then it gets better sometimes, and then it drops again. So there seems to be an inconsistency in the way the application is responding or performing. So it does establish the problem that certain North America users are experiencing some kind of performance impact with Dropbox. Now we want to know why. So now let's look at some of the telemetry that we've collected, and the application performance telemetry that we've collected shows elevated values more than accepted or normal thresholds for good application performance. So we have established the fact that there is some kind of performance impact. There's probably a significant amount of latency that's introduced, which is why even TCP handshake or SSL handshake, or the time taken for the client to get a response to the GET request sent, that also seems to be high. So there seems to be some kind of underlying network layer issue. Now, when I look at some point in time data, I'm looking at the hop by hop insights. So at 325, when the performance is good, it looks like North America users are connecting to a Dropbox location, which is served from North America, basically a North American web server. Now, when I look at a point in time when the experience was bad, I can see that the users are connected to a different location, an APAC region, basically. So this indicates some kind of underlying DNS resolution issue where the Dropbox FQDN is getting resolved to a geographically distant web server. So, which is adding a natural amount of latency to the application. So the North American users are, when connected to the APAC web server, are experiencing slowness in applications, and that's clearly isolated here. So troubleshooting something like this is not easy, especially when multiple management solutions are used. But what we are offering here is a single dashboard, holistic view across the organization, where we are able to surface regional or global experience issues. And not just surfacing, we are also able to correlate it to a root cause event, which could potentially cause the problem. I also wanted to show you some of the visibility, additional visibility capabilities that we offer. What you're looking at here is the capability to monitor a suite of applications also from the cloud agent. So I can have a Microsoft 365 suite where I can monitor all of the Microsoft apps, and I can get visibility into not just the individual application experience, but the overall application suite experience. And we can also get visibility into hop by hop insights. So this helps to establish if there was an application issue, because what you're looking at here is just cloud to cloud monitoring, completely independent of any of the other infrastructure dependencies. Let's look at the next use case, where we have a capability to monitor all of the infrastructure services, the critical infrastructure services. So let's take an example. Let's say users are complaining that a private application hosted in an on-prem data center is inaccessible, or the users are having degraded experience. Now, to determine the root cause of something like this, help desk team would typically require several escalations from L1 to L2 to L3, and then a data center network administrator would have to be involved. So there are multiple teams that will need to come together in order to isolate this problem. And also, it takes time to understand that this is not a single user problem, but then there are multiple users who are raising these tickets. So at several stages, there is a lot of manual correlation to understand the size of the impact, to understand where the problem lies. With AI-powered ADEM, we are continuously monitoring infrastructure services. We are monitoring the data center health, the overlay health of the service connection. We are constantly checking the health of the BGP neighborship, the auth server, DNS service. We are also able to constantly monitor resource utilization. If there are any configuration commits that have gone in that might have potentially broken anything within the infrastructure. So we are able to continuously monitor all of this and automatically identify when a problem happens so that the problem is surfaced even before multiple users start reporting that problem. So this proactive notification enables administrators to curb the problem, to limit the scope of the problem, and address the issue immediately. What you're looking at here is an email notification that a network administrator received. So basically, an incident has happened because of which private applications hosted in the data center are unreachable or not accessible. So an incident was raised and the network administrator is automatically notified. In this case, the administrator has chosen to receive email notification. We also support webhook integrations, and we also have native ServiceNow integration, where we are able to automatically convert an incident that is raised into a ServiceNow ticket for heightened visibility. Now, when I click on this email here, I'm automatically taken to the incident on the Prismaxis portal. And this incident gives me a lot of information about what's going on with this problem. So I get this email notification, I'm automatically taken to the incident, and immediately I see there are around 1,300 users who are impacted because of this problem. And it says the service connection for this particular data center site are down. Now, I'm looking at the telemetry that we've collected for this particular data center site and service connection. So I can see when the availability of the service connection or of this data center site was impacted. I can look at the throughput utilization for this particular site. So it looks like when the service impact happened at the data center, there was no traffic that was able to go through. And we are also able to get information on the user count, basically the number of users, the active sessions who are trying to access these flows. And I'm also able to get visibility into per tunnel details, per service connection details. So I'm also able to get the availability data and the round trip time. So the round trip time indicates the latency that is incurred on the service connection path. So say, for example, if there is congestion and there's significant amount of latency is experienced, we can see this time series data that's configured. So in this example here, in order to get this visibility, enterprises would have to enable tunnel keep alive monitoring. In this example here, the keep alive monitoring is probably not enabled, which is why we are not able to see the round trip time data. But once it's enabled, we will be able to capture the round trip time as well. Now, I can see here that the data center service connection site is down. And right here, you can see all the different events that got correlated. So let's say the data center site had a service provider network flap or a network down situation, because of which the VPN goes down, the BGP neighborship goes down, and perhaps the service connection has two tunnels, a primary and a secondary WAN tunnel, and because of which there are two BGP neighborships built over each of these tunnels. So there are two BGP neighborship down events, two tunnel down events. Now, these are all independent events. What has been highlighted and what has been notified to the network administrator is just the main event that he should be focusing on, which is the data center connectivity is down. All other events, the child events, are automatically correlated using AI/ML, and these incidents are associated with the primary incident, just to make sure that the visibility of the actual incident that matters is heightened for the administrator. Now let's look at another example where there is a branch office performance issue. So users working out of a particular branch office are complaining that their application experience is poor. Now, anyone who comes from the networking world, I come from the networking world, it is an extremely complicated multi-step process in order to identify where the problem lies. because of the several checks that need to be done. So the checks need to be done on the WAN circuit, the overlay, the infrastructure, the data center infrastructure, and then there's several levels of analysis that needs to be done to find out where the problem is happening, layer 3, layer 4, layer 7, and what are the events that we are seeing in the network. So there is a lot of data, uncorrelated data, which needs to be brought together to understand where the problem lies. With AI-powered ADEM, we are continuously monitoring the branch infrastructure, and we are able to automatically identify when something goes wrong. So right here, we are looking at Prisma Access incidents. And similar to what I showed you for the service connection incident, a network administrator can be notified either through email or webhook, or even a ServiceNow ticket can be opened. So what we are looking at here is an incident that has been raised for branch office performance impact. When I click on this incident, I can see that the root cause event is that the round trip time over the VPN was significantly higher. So significantly higher than what is normal for this branch office. So we are not just detecting a problem, we are learning the enterprise network, and we are detecting, or we are raising an incident only when we see an anomaly. We know what is normal, we've learned the baseline, so only the anomaly is highlighted. So when this incident is raised, we can see the throughput utilization, the availability metrics for this particular site, and then we see the round trip time. So it does look like there is some kind of issue where the brand site is experiencing on and off some kind of congestion, or there is a latency that is introduced in the VPN path, which is contributing to users' application experience when working out of the branch office. We can also see here there is BGP telemetry that is collected, so we can look at the BGP prefixes advertised and received over the VPN path between the branch and Prisma Access. So this also helps to isolate if is this a BGP neighborship flap, or is this an underlay flap, or is this some kind of VPN congestion issue. So what is the root cause? Where does this problem lie? So all of the supporting telemetry is available in the incident. Now, let's look at another use case where a single user is raising a ticket saying his access to a certain application was available earlier, but it's not there anymore. Now, before we go into the use case, if we were to visualize, if someone came and told us, hey, my access was there yesterday, but I don't have access since morning. It's very difficult to solve a problem like this, considering the number of infrastructure hops, number of the analysis that we have to do across multiple solutions, multiple tools in order to find out where this problem lies is a very, very challenging question. With AI-powered ADEM, we have introduced a natural language query interface called Access Analyzer. As the name suggests, the Access Analyzer takes a natural language query, and it's going to say why the user's access is limited or degraded. So we go to the Access Analyzer, and I'm going to show you how to run a query. So we start a new query, we submit the query here. So this user, Bob Green, is not able to access Slack from a particular device. The query has been submitted. In less than a minute, we are able to get the verdict for this user's access issue. So when I click on this query, this is completed now. I can see the different segments that have been analyzed, the multi-segment analysis that has been performed, and I can see which segment has been isolated as a problem segment. So the user and endpoint device looking good. Network issues, there are no network issues for the user. Application health is good. It's a security policy that seems to have a problem, which is blocking this user. So now let's see what is the issue that's happening with the security policy. So when I go down to the security policy, I can see that there is a security policy which says endpoint hygiene check failed if the firewall is disabled. So this security policy has been identified as a potential root cause for the user's access issue. So the company has enforced a policy where if users do not meet compliance requirements, if the posture check fails, then their access to critical corporate resources is limited or blocked. So that's what this security policy does. Now, it looks like this particular user has lost his access because of the security policy. Likely he turned off his firewall and he is now blocked by the security policy. So within a minute, we have an answer to the user's access issues. So this is extremely powerful considering the number of monitoring solutions that enterprises have today, and considering a lot of time is spent in correlating all of the data collected from these several siloed management solutions. We are able to do this multi-domain analysis independently and automatically correlate all of the data and show this information to the administrator. So this helps to drastically bring down the time taken to detect a problem, and hence the time taken to remediate the problem also is significantly improved.